In this film, we will introduce the concept of component, applied to lean automation methodology. In this presentation, we created an empty project, and then added a new component, called X751A. The empty project already has a component, called Spin, which automatically generates all the reports available in the empty project. With the new component, is added to the design, the schematic of a feeder bay, controlled by the X751A, as well as a bay detail screen, as suggested by the manufacturer. In the movie, after including the component, we create 3 feeders, with type X751A, and, through a routine called deploy, it instantiates all the points of each feeder, generating points address, alarms and historian rules. Once the component has already been tested, there are no errors in the customization of tags, screens, reports, command windows, etc. The generation of components is very simple, and allows the creation of libraries of features, such as the example program, which is created in minutes. Manufacturers and consultants can create component libraries with the best practices of using their equipment. So, instead of manuals, documentation, etc., showing everything that can be done, with the relay, a component is created where everything that can be done is implemented and working. If there are optional features, depending on the relay model, these options are created in the component. The layout of the feeder, as well as the detail screen associated with it, were copied from screens of the relay manufacturer's website. They are examples, which can be changed, depending on the desire of the user. The drawing tool is based on Windows Presentation Foundation and is very powerful. Let us create a project from the beginning, that is, from the default new project. The name of this project is Demo Component. In the just created project, there is already a first component, called Spin Component. This one, as we will see later, deploy all existing reports in ActionNet, without the user doing anything for it. To this component we will add the new component called X751A. This new component is considered to be developed by the manufacturer, or by an independent consultant, and have all the points of the relay, suggested for use in a feeder bay, with its IEC 61850 addressing all events and alarms associated with the relay, all measures that go to historical. In addition, it already has an object that represents the feeder's schematic, and a detail screen of the feeder, built from the manufacturer's screen suggestion in the website. It is the relay best practice according the manufacturer or consultant. After adding the X751A component, in Edit, Objects, we have a line that describes a feeder, called AL01, as you can see, it is of type X751A. Let's create 2 more feeders, by copying AL01 and pasting with the names AL02 and AL03, respectively. In the X751A component, in addition to a line describing a feeder, there is also an empty home screen and a detail screen of the selected feeder. As can also be observed, the list of variables that go to history is empty, as well as the list with variables associated with alarm conditions, and the list of points with IEC 61850 addresses. After creating the 3 feeders, with type cell 751A, we will instantiate it, creating all the points of the existing bays, in this case, 3 feeders. To do this, the deploy extension is executed, which generates, for the 3 feeders, the list of variables that go to history, the list of variables with alarm conditions, and the list of addressable points in IEC 61850. After the execution, we verified that the 3 lists were correctly filled. To create the layout of the 3 feeders, on the Start screen, we will copy them from the Tags Objects screen and paste them into the Project Initial screen. Once the symbol library has a symbol named X751A, the system understands that these feeders are associated with that symbol and paste them on the main screen in the order that they were copied. In addition, we can observe that each scheme already is correctly associated with the respective feeder, AL01, AL02 and AL03. Now let's run the project and show that it is already operational. When the project starts, a user code and password window is opened, and the introduced user has already associated a set of permissions and usage policies. To facilitate the association of values to the feeders variables, we will use a debug window called Watch. To include feeders variables in the Watch window, we go to the IEC 61850 point list in the Studio project and copy all the points, and next, we pass them into the Watch window, and it's done. All variables are in the window. Through the Watch window, we will include values of analog and digital variables in the feeders 1 and 2. We will enter with the currents and powers of these feeders, as well as the state of the circuit breakers, switches, and some protections. As we enter with the values of the variables, these are shown in the screens, and events and alarms occur, as can be seen in the last line. When you click on the relay drawing of any feeder, the system automatically navigates to the detail screen of this feeder. We associate the current IA with the real-time trend graph shown in the detail window, and we make several changes of this value through the Watch window, showing that the graph is changed. In the sequence, we change some digital variables, shown on the detail screen, and they are signaled on the screen. We navigate to the current alarm screen, and normalize some alarms, and they are instantly removed from the list. We navigate to the Events screen, and initially, classify the screen in order of events priority. Then we classify it, again, by timestamp and, in the end, we classify the events by name, that is, we present all the events that occurred for each tag name. To better understand the technology of lean automation and components, let's return to the design environment, and we'll unmake the symbol of a feeder. We note that this is composed of dozens of small symbols. Each one, after being built, is individually tested and then grouped to another ones, creating circuit breakers, switches, etc. At the end, in this example, we have a symbol that is associated with a feeder's bay, and it has all the features of that bay. Thus, double-click on switches and circuit breakers open command windows where it's possible to open, close, block, enable, disable equipment. Finally, all the symbols that, in this example, represents all the relays of all utilities bay. They will be included in one library, called here, XEL. In the component, you can deploy all the default settings of the relay, with option to activate or not. For example, considering the X751A, you can consider the use of load shedding, arc flash protection, and other usual protection schemes in feeders. In the case of protocol IEC 61850, the correct logical nodes will be used for the association of the points, guaranteeing the proper use of the protocol. Company knowledge is available and will be transmitted through the use of components. Employees will always customize correctly